Hello everybody, today we'll be talking about improving the page performance, faster by design, performance patterns for React and Next.js. I'm Krish, I'm a software engineer too, I'm card experience team. I've been at Granger pretty much all my career, 3 years into it, and very much proud Grangerite.
Hello everyone, I'm Gavin. I'm a software engineer too as well on the checkout side of Granger. Krish and I actually started at the same time, so like almost 3 years now. Going over the topics that we'll cover in this presentation would be like the entire journey of optimization and like the measuring and like actually quantifying the performance post and the aggregate set of things as well. So we'll be starting with parallelization, caching, server-side rendering, like reducing the bundle size, like using React compilers and actually lighthouse analytics as well.
Perfect. Thanks, Gavin. Firstly, let's start with parallelization. Let's say your page has 4 calls, or let's say your page has 3 calls that you're making. Instead of making those 3 calls one after other, it's going to take, let's say, 100 milliseconds for each of your call. If you can make the same exact call simultaneously, parallelly, it's going to just take you 100 milliseconds. For example, let's say you're on a web page where you get contact info from one of the APIs, you get subscription info from one of the APIs, and store credit information from the APIs, and all 3 of them has no link with each other, then there is no point of just waiting for one call after the other. We can directly make a call parallelly so that they all can happen simultaneously and give us faster results. And this doesn't just needs to stop with running them parallelly one by one. We can also separate them into batches. Let's say you're on a page where you're making 8 or 9 calls, and your first call is the key call, which gives information for most of your next calls. Then you can start thinking about combining the next calls by groups. One of the things that we have done here is, let's say you're on a page where you get user session, and then the next calls like profile, permissions, purchase history. These 3 calls need something from your first call. Now just use your first call information and start batching your next set of calls. That way it's easier for you, it's going to be better for the performance. That way it's going to be loading faster. In this scenario that we have been presenting here, if you run all these calls sequentially, one after other, it's going to take approximately 800 milliseconds. Now if you try to batch them and optimize the performance by batching and calling some of the calls together, it's going to bring down to almost 400 milliseconds. That is cutting the page down speed by 400 milliseconds. It's going to add up a lot more as you do more and more calls. So that's why I've been loving parallelization and trying to do as many parallel calls as we can. The next concept is caching. As much as parallelization, we can also cache some of the API calls for better page performances. There are various levels of caching that can be done, but today let's specifically focus on framework and also client data caching. Framework caching is from the next side. Let's say you're calling an API which does not change data pretty frequently. Start thinking about caching that call very early on. That way, when same call happens next time for the user, it's going to load up a little faster. So start thinking about time to live for the specific call. This can also be done on the React level, not just on the Next.js level. As soon as a user is getting some information, start thinking about like what information that can be cached early on, so you don't have to keep calling the same data. That way it's going to improve the page performance and it's going to load faster, and sometimes even like adds up to be more time and it's going to go much more smoother. But here's the catch. This data is pretty volatile. Things can change, so you have to understand what you want to cache and what you don't want to cache. For example, store information of Granger branch. It's not going to change pretty frequently. There will be times where it's going to stay pretty stable. So for hours and days, you can cache this call. Whereas things like order status or availability of a product can't be cached very much because it's going to change pretty frequently. That way, understand what you want to cache very early on while coding. That way, it's going to be much better. And also never cache things like payment information. They're pretty sensitive and also going to change. Now, adding on to server-side rendering. This is another way to optimize the page performance. It's going to give us fastest LCP and FCP. HTML is going to arrive ready to render. That way the page is going to perform much better. And also better SEO. Crawl will see full content and it's going to be faster and less client-side JavaScript code. Adding on to RC, React server components. Try to render the components on the server side, so it's going to be much faster and you'll get better information by the time you get onto like JavaScript to the client side. One of the examples is, let's say you're having an analytics page where you get some important data of chats. Here, things like footer, header, or even the title of the page does not need to be rendered on the client side. These are the things which you know are going to stay consistently same. So things like this can be rendered on the client side. In the same example, let's add on the suspense tag. The suspense tag helps you with getting the shell rendered beforehand. For example, the data is going to flow in later, but the shell, the component around it is going to run much faster. And lazy loading, already Krish covered it, but things like Adobe Analytics or anything related which the customer does not see directly can be lazy loaded. And finally, the React caching, as I've mentioned earlier, try to don't call the same API again and again. Try to like cache whatever you can so that you are not making any duplicate calls. I'm going to pass on to Gavin.
Okay, now that we have moved to the server side, let's make our target to keep the server side rendering lightweight. To do that, like by default, these components enter the server side without an explicit directive. But then if you use a use client directive, that's a clear indication to be rendered on the client side. So we want to ensure that the use client directive is only there on like leaf components unless it's absolutely necessary. So that way, like things are rendered on the server and then transferred to the client. Like we plan to like minimize CLS props, like move across the boundary. So we will not pass in the entire object to the client side. So instead, just pass in the specific props that is needed to render the component. So that way, like one, we don't overexpose the data to the client browser, and like ensure that the data transfer is like minimal as well there. Now moving on to reducing the bundle size. There is the barrel file trap. What this is basically, if we don't import like the absolute like edge of an import, it sometimes imports like a higher bundle size during build time. It doesn't really like affect a lot of like runtime performance, but then like build and dev builds are affected by it sometimes. So if for example we go with the import with like a button and import like a button on the sec on a direct import, that imports like lesser number of modules in our app. There's a experimental next config wherein you can use like optimized package imports, so that does like dynamic tree shaking and like checks for like which packages are available on like leaf nodes as well. Moving on to like more on like optimization on the bundle size. We have okay, so this is not really bundle size, but then in terms of like heavy components, what this does is if we have like lazy loader or like next dynamic, what this does is we can like delay the loading of like heavy components on the page, so we can like not have a blocker state for the user to like stop the interactivity on the page as well. There is an option for like having dynamic imports for behind conditionals. So this is like this has been really helpful for like doing like feature releases. So we could have like a import behind a feature flag, so that way we can do a conditional import of a package, and that way that package is like never exposed without the absolute change of the feature kernel. In terms of like measuring bundle size, there is the next bundle analyzer that helps analyzing the bundle and how exactly the tree is, how the tree for the imports are like forming as well. There's this source map explorer, but then there's not been like much development on that recently. But then that's a cool tool as well to measure. Moving to React compiler. So this has been like a very cool tool that we've been experimenting with quite a lot. So what this does is this eliminates the use of like explicit tagging for memoization of components. So we can like move away from like explicit use memo and use callback, because the React compiler during build time, I know it does take a little bit longer during build time, but then it will automatically memoize components and will stop unnecessary renders of the page. Like over time, the setup of like React compiler has changed a lot. So this is like the initial like Babel React compiler setup, which I mean like ESLint plugin with React compiler is really good. So it helps a lot with like identifying problems with like React compiler syntaxes. In Next 15, it was like experimental, but then recently with the latest updates in Next, it's no longer experimental. So we can in Next config you can straight up like import React compilers. Yeah, so this eliminates. Yeah, so with terms of React compiler, it needs to follow like a fixed set of React rules that they have like published on the website, and like purity of components too. So if it matches those rules, it does memoize components well to like reduce the renders. Like if anyone wants to experiment, there's also there's a tool published by Meetup which tests how well your app is working with the React compiler. So that like gives you like a base estimate of if that memoization is gonna work out, and if your components are really compatible with like how memoization is architected. So it does come with like some drawbacks. So if there is like violations that are ignored, so if there are like violations during build time, it doesn't really doesn't stop the build process. It still continues with a warning. So they could be like silent failures, and debugging like the code is compiled code is like harder. And then it like for the experimentations that we have done, like we saw a marginal increase in build time, but then there could be an increase in build time as well. So that's it for the React compiler. Now moving on to like how do we actually quantify if things are working fine and we are like actually improving with each step that we are taking in our application. So we do so Lighthouse is a very cool tool to measure like how well the page is performing, and these are the Google ranking metrics that they have. And at Granger, we always go with like the continuous process of like measuring, optimizing, verifying if everything meets standard, and then repeating the process in time. So that's it. Thank you. Yeah,